We are going to use a fundamental counting principle to count permutations. We are going to use factorial expressions, use a permutation formula, find the number of permutations whenever you have duplicate items. The permutation is an ordered arrangement of items that occurs when no item is used more than once. The order of arrangement makes a difference. So let's look at the how many different ways you can arrange A, B, C. For letters A, B, C, or you can do B, C, A. You can do C, B, A, B, A, C, C, A, B, and C, B. Those are all the different ways. So there are 6 ways. Okay. Let's look at how we could count permutations. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of books makes a difference to you? Okay, you can choose any of the 7 books for the first position. So you have 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. So there's 7 books. So the first book that you put on the shelf, so let's say you have a bunch of books laying on the floor. You could pick any of the 7. So that means you have 7 outcomes. Well, now that you've taken one away, there are only 6 on the ground that you can choose. So now our second book, there's only 6 outcomes. You've taken one off the floor, so now you only have 5. So you have 5 outcomes that you could or 5 options you can choose from. Well, now you've taken that 5th book. Now, or I guess really a third. Now you only have 4 to choose from. You get the idea? Now we only have 3. Now we only have 2. Now we only have 1 left on the floor to pick from. So the fundamental counting principle says we multiply these to find all possible outcomes. So we do that in the calculator. A lot of times I like to do these in my head, but not this good. 7 times 6 times 5 times 4 times 3 times 2 times 1. 5,040 different outcomes. So instead of listing out all the different ways you could put your books, because that would take forever, you can just multiply your outcomes. So same with this. So let's think about, we have 3 letters we're going to put on together. So the first letter, we have all 3 letters to choose from. So we have 3. So once we pick one, now we only have 2 letters to choose from. Now we only have 1 letter to choose from. So we multiply those. 3 times 2 is 6. 6 times 1 is 6. Same thing. Same thing as listing them out. Or you could do a tree diagram like we did in the last section. But I'm going to teach you something a little bit easier. So see how we did the 7 times 6 times 5, 4, 3, 2, 1? Well, this is actually called 7 factorial. It's written as 7 with the exclamation point. That means you're going to multiply 7 times all the positive integers that are less than 7. So that's why we do 6, 5, 4, 3, 2, 1. So that is called factorial, 7 factorial. So we can actually do this in our calculator too. So 7, and if you have a calculator like mine, you can go to math over to probability. So we're going to be in this section of the calculator, and number 4. There might be an easier way to find it. This is the way I use. See how it's 540? Same thing. 0 factorial is always 1. So let's look at example 2. There are 8 performers who will be presenting their comedy acts this weekend. How many different ways are there to schedule their appearances? So if you're looking for all the different ways to schedule their appearance, like you have the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, then this is where you use factorial because you're finding all the possible ways that you can list them out. So 8 factorial. 40,320. And if you don't have a calculator that has this option, you can always do this. And you'll get the same answer. All right, let's look at how we can simplify fractions that have factorials in them. Instead of putting this in the calculator, I'm going to show you without. So what 8 factorial means is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What 5 factorial means, 5 times 4. So I'm going to go ahead and just put it directly under the same number, like that. And whenever you have a number divided by itself, it cancels. So look at all these numbers canceling. So really we're left with this, 8 times 7 times 6. Because we're able to simplify common numbers that are on top and on bottom. 336. Okay, another way that we could do this, we'll do it on this next one, is instead of writing 5 times 4, blah, blah, I could have wrote 5 factorial here and left the bottom as 5 factorial and then just marked those out instead of listing all of those. So that's what I'm going to do on this one. So I'm going to go and write my numbers all the way to 21. And I'm going to put a 21 factorial there. And this is 21, so that's why I stopped there. That way I can simplify 21 factorial out because something over itself equals 1, so we're able to cross them out. So now we're just left with 26 times 25 times 24 times 23 times 22. There we go. Okay, the next one, we are going to, let's just do 5 factorial, and let's do 5 minus 2, so that's a 3 factorial. So we'll go to 3 factorial. And so the numbers in front are 5 times 4. So the 3 factorials simplify out, and we're left with 5 times 4 equals 20. Okay, there's a formula for permutations whenever you're not using all of them. So this example, we were using all 8, and we were finding the order of their appearance. So the position matters. Number of possible permutation of R items are taken from N items. So N is going to represent all items. So I'm going to put total items. And then R is going to represent how many you're choosing. From the N item. So N is going to be your larger number. That's all your items. R is just how many you're choosing. So we use this formula, N factorial over N minus R factorial. So in this case, N is 7, R is 4. So the P represents a permutation. When we do the next section, we'll have a C here, and that represents a combination. So we're going to do N factorial, so 7 factorial over 7 minus 4 factorial. So 7 factorial over 7 minus 4 is 3 factorial. So this will be 7 times 6 times 5 times 4, and then times 3 factorial over 3 factorial. Those will simplify out. We're just left with 7 times 6 times 5 times 4. 840. In the menu that we had, where the factorial was, there's actually a permutation formula. in there. So you have to put in your number first. So you're going to put in, so let's say it's 7. Then you're going to go to math, over to probability, and down to number 2, NPR. And then R is 4. If you have a CE, you will just do NPR and then you replace N with 7 and R with 4. Don't forget to put in your R value right there. And it equals the same thing. So if you have a calculator that has this option, use that. If you don't, then you're going to have to use your formula. Okay, let's keep on going. You and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, operating manager, and a treasurer. In how many ways can those offices be filled? Okay, so we have you and 19. So that means that there are a total of 20 people. And then we're choosing 1, 2, 3 officers. So we can use permutation because it matters which office a person gets. It's not like they're just picking 3 people to be on the committee. It's one person CEO, one person operating manager, and one person as treasurer. So we have to use the permutation formula. So you can put this in the calculator like this, where 20 is N and 3 is R, or you can use the formula. It's N factorial over N minus R factorial. And this is 17 factorial. So I'll do like that. You can put in the calculator, you can do I'm going to do this one so you see that again. So 20, you go up to math, over to probability, down to NPR, 3, 6,840. You could do 20 times 19 times 18. Same thing. So that's how many different ways you can fill those 3 positions. Okay. In a race in which 7 automobiles are entered and there are no ties, how many ways can the first 3 finishers come in? So does it matter who's in first, who's in second, who's in third? Absolutely. So position matters. So we have 7 automobiles, and we are coming up with our first 3 positions. So that would be that. And so you can do 7, or you can do your fraction again. So it'd be 7 factorial over 7 minus 3 factorial. This is going to be 4 factorial. 7 times 6 times 5 times 4 factorial over 4 factorial. 7 times 6 times 5. You put in 7. Go to math. Probability. NPR. 7 times 6 times 5 is also 2 times. Okay. One last type of problem that you're going to see is when you have duplicate items. So let's say you are, well, this is an example. How many distinct ways can letters of the word Mississippi be arranged? So see how S's are repeated, I's are repeated, and P's are repeated? So it doesn't matter if it's this S or this S that comes first. That means the same thing. So we have to use a different kind of formula. So it's N factorial over P factorial, Q factorial, R. P, Q, and R or S, whatever it is. Those are the items, but how many of those items there are. So here we have 4 S's. So P would be 4. We have 4 I's. So Q would be 4. R would be 2 P's. So R would be 2. Okay. So we're looking at what are the repeats. So first we need to figure out what an N is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we have to figure out what's repeated. So I is repeated 4 times. S is repeated 4 times. P is repeated 2 times. So whenever you do your formula, you're going to do 11 factorial over 4 factorial, 4 factorial, 2 factorial. No shortcut here. You're just going to put it in. So I'm going to do my fraction and do the factorial. Go back to math, probability, number 4. There we go. 35,650 different ways. All right, that is it for our notes.